So I'm here to introduce you today to Ofoot. As we've heard from David and Dave, we know quite a bit about the impact of agriculture in general and organic ag in particular, and what impact they're having on greenhouse gases. But there is a tremendous amount that we don't know. And at WSU, we've now started a project called Ofoot for organic farming footprints. This is a new project that combines laboratory and on-farm research, along with a lot of guidance we're getting from producers to develop information that's specific for organic systems, to improve our research models, and to develop a user-friendly computer program. Let me take a minute to explain a carbon footprint. We've used this term a little bit, a footprint. And you can use the word footprint to mean any sort of impact that you're having. In particular, it tends to mean the environmental impact. And a carbon footprint specifically means the amount of CO2 equivalents that are emitted and stored. And David explains that all of the different gases can be related back to their CO2 equivalents. So in organic agriculture, we do use tillage, and there is going to be a carbon footprint or net emission from the energy that's used to create the equipment and the fuel that's used to complete a tillage operation, and probably some CO2 coming out of the soil at that time too. The nitrogen impact from organic agriculture is likely to be quite small compared to most conventional systems, but still there. Carbon storage is an area where agriculture in general and organic ag in particular may have a negative footprint, so we can act as a net sink. Now, these things can also be combined then in a multidimensional total footprint. One example of this was done near Washington State University in Pullman, Washington, eastern Washington. It's a dry land agriculture. And this is looking at a wheat, barley, wheat rotation with 3 different kinds of tillage. This information was put together by Dr. Zahir and Stockel, who are also working with us on the Ofoot project. So in this case, we can see that these different tillage systems can be approached from many different factors. We can see the carbon storage or the sequestration in red, significantly more in a no-till system in our area. Nitrous oxide emissions, all of them were positive, but a little bit less so in no-till. Fertilizer production, very much the same in all of them. Fuel consumption was less in a no-till system. And then we can combine all of those in terms of their CO2 equivalents and see that in the no-till system, at least in our area, the total carbon footprint was extremely low. So this is the kind of total footprint we would like to be able to create for organic systems too. In order to do that, we will need to look at the kinds of inputs that are used in organic agriculture. We know that organic systems tend to use a lot more of plant residues and green manures as their fertilizer inputs. So we know that we'll need to do experiments in the lab and field to track carbon dioxide production, also to track the available nitrogen and phosphorus, because these have an effect on how much nitrous oxide can be produced. We'll watch the changes in soil carbon over time, and we know that these change quite slowly, but can be very important if we're looking at that potential sink. And nitrous oxide production, we know will be a very dynamic and important factor to track in very short time periods. So the research will include looking at many different plant materials as residues and green manures to track their effect on all of these factors. We'll also be using, in cooperation with Western Ag Innovations, a fairly new tool called Plant Root Simulator probes. These probes act to take up nutrients in a very similar manner to how plant roots take up plant nutrients. We can then analyze from the probes how much nutrient was available and likely to be taken up by the plants over a particular period. When we do this, we can not only then estimate what was the potential plant nutrient supply, but if we have a plant growing in soil and nitrogen, for instance, is available, then the plant is able to take that nitrogen out of the soluble pool and thereby reduce the potential nitrous oxide production. So what we want to do is to reduce the amount of available soluble nitrogen at any time by having a plant taking it up when it becomes available in the soil. So as a result of all this work, we would like real individual farms to be able to answer questions. What is your farm's footprint? How much carbon is your farm storing? Which greenhouse gases are being produced by your practices? And how could they be reduced? So with this work, Ofoot aims to bring answers in a user-friendly tool. And the concept here is that a person with very little training would be able to use a computer program. Now, the farmer will understand their soil, what inputs and managements they use, and will be able to input that information. Other information can come from online sources and other ways of estimating, and we'll be able to produce many different outputs from the model: estimating yield, estimating change in soil organic carbon, greenhouse gas emissions, even the water, nitrogen, and carbon balance, and overall, what is the footprint?